Now a bit more on identifying and using these so-called two-force members. So one, how do we know if a member in our frames of machine is a two-force member? Again, every member in a truss problem was a two-force member, but really what was that requirement? So we can identify a member as being a two-force member if it has pin connections at exactly two locations. It cannot be more than two. It cannot be a pin and a peg. It cannot be a pin and built into the wall. It has to be exactly two pin connections. And this is what we saw in trusses. A requirement for something to be a truss problem is that every member had to be pinned together. Additionally, that member can have no forces and no couples acting along its length. Again, this was another requirement in our truss problems, is that the loading was only occurring at pin connections, not along the length of a member, and we were ignoring the weights of the members, which would also typically have their center of gravity along the length of the member itself. Now, these are sufficient conditions to be a two-force member, but not necessary conditions. So if these two things are true, it is definitely a two-force member, but things could be two-force members or turn out to be two-force members, even if it violates one or both of these, depending on how it's connected into the rest of the system. But by inspection, this is how we can tell immediately that we have a two-force member in our system. And what's the consequence of being a two-force member? Well, it's exactly what we saw in our truss problems. Two-force members have their forces act along the axis determined by the two pins at which it's connected to the rest of our system. If something is not a two-force member, it can exert force perpendicular to that axis, and it could be exerting a couple as well. But two-force members, we know automatically the direction of their force is along the axis determined by the two pin connections. So how is this going to be helpful to us? Well, one, there's no need to draw a free body diagram of a two-force member because all the information from the free body diagram is going to tell us is what we're already going to know, is that the force is going to be directed along that axis. So we can identify something as a two-force member, and then right away, any diagram on which it's acting, we already know its direction. We do not yet know its magnitude, but we will know its direction. So it can save us some time, it can save us some equations. Now, in the flip side, and kind of like what we saw with the zero-force members in the truss structure, not identifying something as a two-force member is not going to mean that we cannot mathematically show it's a two-force member. This is a kind of an optional time-saving technique. It's not going to be required. The worst case, if we do not identify something up front as a two-force member, is it's going to add another free body diagram and another equation into the system that we have to solve. But as long as we can generate a solvable system of equations, it's not going to be a huge deal. On the flip side, though, if we identify something as a two-force member and it turns out that we were incorrect, well, now the entire problem is likely going to be wrong as we go through the solution procedure because we made an assumption or a simplification that was inaccurate. So if we are uncertain, the safe thing to do is just treat it like any other member, and if it turns out to be a two-force member, the math is going to let us know that. Now again, where have we seen two-force members before? Well, every time we had a cable or a rope, those were two-force members. We always knew that in those elements, the force was directed along the axis of that rope or cable. And as we saw in trusses, every member of a truss was a two-force member. When we were doing method of sections, method of pins, we always knew the direction of that force was along the axis of the member. And then what we still needed to find was what was the magnitude of the force in each of those members.